Now, dear students of grade 11, let's continue training exercises about limits and especially the limit at a point. Here is an example. We have to find the limit as x tends to 2 and as x tends to minus 1 of x squared plus 3 over x squared minus x minus 2, and similarly we have to find the limit as x tends to minus 1 of the same function x squared plus 3 over x squared minus x minus 2. First of all, as I keep telling you, we have to care about the roots of the denominator because problems are usually as x approach those roots. So the roots of the denominator using the calculator, every time I'm showing you how to use the calculator. So to get the roots of the denominator, they are minus 1 and 2, or we can use the idea. If you don't have a calculator, you can use the idea of, if it works here, a minus b. Yes, it works. A minus b, then it is 2, and plus c is 0. Then one of the roots is minus 1 and the other root is minus c over a, which is minus 2 over minus 1, or minus 2, which is 2. So here are the roots of the denominator and here are the values we are going to study the limit at. Now, why did I start with the table and why am I going to use the table for minus 1 and for 2? Why am I going to study the limit at minus 1 minus and minus 1 plus, and similarly at 2 minus and 2 plus? Because whenever I evaluate 2 or minus 1, I'm not going to get 0 over 0. So I'm not getting an indeterminate form. That's why we start studying the limit at minus 1 minus, at minus 1 plus, at 2 minus, and at 2 plus. And to do so, we have to use the sign, the table of signs. Here are the roots, and as you know, a is positive. It's the coefficient of x squared. So we use the idea of same, opposite, same. So plus, minus, plus. Here is the region where minus 1 minus is. Here is the region for minus 1 plus and for 2 minus as well. And here is the region for 2 plus. And as we mentioned before, minus 1 minus means approaching minus 1 from the left. Minus 1 plus means approaching it from the right. 2 minus means approaching 2 from the left, and 2 plus means approaching 2 from the right. It doesn't have anything to do with sign of minus 1. It doesn't mean negative or positive. No, it means approaching from left or approaching from right. And here we go with studying the limits at 2, for example. We started with 2 as required here. So limit as x goes to 2 minus of this function, we just substitute here. 2 squared is 4 plus 3, it is 7, and directly, as I told you previously, because 2 is a root for the denominator, so you directly put 0. Now 0 minus or 0 plus is according to the table. We are talking about x approaching 2 minus, then 2 minus is in this region, which has a minus sign, so we put 0 minus. That's a negative number. Now 7 divided by 0 minus is minus infinity. Okay? Now for x approaches 2 plus, limit as x approaches 2 plus of this function is similarly 7 here and 0 down. 0 because we are talking about this region, 2 plus, and the sign is plus, we put 0 plus. 7 over 0 plus is approaching plus infinity. Now according to minus 1 minus in this region, we substitute here. Minus 1 squared is 1, plus 3 it is 4, over in this region we have a plus, so we put 0 plus. 4 over 0 plus gives plus infinity, is approaching plus infinity. And similarly, if we are studying the limit as x tends to minus 1 plus, we mean this region, we have to put 4. Similarly for that one, minus 1 squared plus 3 is 4 over 0 minus, and the answer is minus infinity. Now we say that there are two vertical asymptotes for this function. One of them is x equals 2 and the other is x equals minus 1. These are two vertical asymptotes because the limit at these values is infinity. Now what about the horizontal asymptote? If you look here, taking the highest power at infinity, it is going to be 1. So the limit as x approaches infinity is 1. That's why y equals 1 is the horizontal asymptote. And here is the figure of that function. Notice the vertical asymptotes at -1, at 2, and the horizontal asymptote is y equals 1.